real quick review of the agenda for those people who are just walking in or have very bad short-term memories like I do. Now we're going to talk mostly about the data model. I do want to apologize a little bit. The theme of the different days might not have been entirely clear. So today is definitely going to be a little bit more technical than tomorrow. And tomorrow you're going to see a lot more of the business case side of USP, real world use cases, the operators talking about stuff like that. So today we're diving into some of the nitty gritty. And this was actually based on feedback from the last summit. People said it was too high level. And then, so we're like, okay, here we go. But it all coalesced around a theme of the transition from TR-069 to USP. So in the spirit of that, I'm going to be talking about the TR-181 differences between CWPM and USP. Yeah. Because unfortunately, well, also, if you don't remember who I am from this morning, I am Jason Waltz from QA Cafe. We make the CD router, passport test platforms, a bunch of other stuff, great stuff, and we're deeply involved in standards. I have, through QA Cafe and UNH-IOL before that, have been involved in developing TR-069 and USP through Broadband Forum for about 20 years. And I am the host of the Epic Melon podcast, where I talk to human beings like yourselves who are in networking to prove that we are, in fact, human beings. Okay, I'm going to give a little bit of a refresher on TR-181. Daniel hit a lot of those points already and is going to hit them again, which is fine. Repetition is good. And then I'm going to talk about the differences, right? So there are some concepts in USP that we convey through the data model that are things that you either do differently in TR-069 or can't do at all. Those things are things like commands and events, how we do diagnostics, how we do firmware management, how the data model is addressed and the new things you can do, and especially and most powerfully, from our opinions anyway, is the ability to learn what a device does in real time. A little refresher about what makes USP tick. There is the protocol specification itself in TR-069. There is the open source USP agent as a reference, but as I mentioned, there's many other solutions too. There is the test plan and certification program, and I am going in that direction because last but not least is the TR-181 data model, which when we decided to rip open TR-069 and when we were still calling USP TR-069 2.0, the very first bullet, I believe, in our list of design requirements was backwards compatibility, at least to a certain degree. And so what we decided was, rather than making a new data model, would be to reuse TR-181. Now, I realize that this is unfortunate news for those people who are still using TR-98, but come on. As Daniel said, it's been deprecated for a very long time, and I understand that there's a lot of deployments out there, and that it's you can't necessarily fight the knowledge behind it either. Like, there's a lot of people who that's what they understand, but we had to use the newer data model for this for a number of different reasons. So a little bit of the history of 181. The very first data model was TR-98, and even before that, it wasn't in its own specification. It was actually stuck in the document itself. Remember that? So that was Internet Gateway Device. It was largely based on UP and PDM, right? So we were trying to reuse what they had done. But we deprecated it in 2014 because there was a lot of new stuff that we needed to do. During that time, though, we also created Device 1 to model devices that were not gateways. And that was TR-181 issue 1. And so there was a little bit of fragmentation there on how you do things and how things are modeled, how things are addressed. So we scrapped it all and made Device 2 in 2010, which introduced a new non-hierarchical structure for the interfaces and the networking protocols interface stack object, which lets you build what the gateway is supposed to look like. And then we've added all of our additional features to Device 2 since then. What makes Device 2? There are the actual XML definitions themselves. There's the actual TR-181 issue 2 specification, which is the document that sort of outlines what the data model is, what you need to know about it, and then a host of appendices that describe theories of operation for various functions. There's a lot in there. Sometimes we're not putting the theory of operations for things in there. In the future, we're trying to put in the most relevant place and the most accessible place. So in the future, we might just be making new documents for new theories of operation or sticking things in USP like we've done before for things that are USP specific. And then behind it all is TR-106, which is the schema that helps us define those data models. So when we're doing our work at the Broadband Forum, we're updating these things. Let's jump right in and talk about commands and events. So the first major difference in TR-181 between TR-069 USP, TR-069, as we know, defines all of their new functions via new RPCs. And that required us changing the protocol, which stunk. So anytime we wanted to add new functionality from a command perspective, we had to have a new version of CWPM. So what we did with the USP is we stripped it down so that all of the basic messaging is in the protocol. Everything else is in the data model. And that includes both commands and events, but I'll get to events in a minute. For operations, we call them commands, and they are defined in the data model, and they have a special addressing syntax. And here's some examples: reboot, packet capture diagnostics. I will bring up this real quick. So as I was saying, so when we publish TR-181, we do publish it twice. We publish it once for TR-069, once for USP. And so here's an example of a command IP ping that I'll explain more when I get to diagnostics. But the difference is that commands have input arguments that are conveyed in the message. That are conveyed when you call the operate message. So you basically say, I want you to do this command. Here are all the input arguments I want. And then there are various ways that comes back. Oh, yes. Well, I am going to get to that. Right. I'm going to show that. No, but I guess I can show that now. It'll make more sense. So you can see I was using IP ping as the example, right? For a command that has a command like parameter. What do we call them? No, in CWPM in yeah. Right. So you can see here that it's kind of a hodgepodge where we stuffed a bunch of operational things into a parameter to get you to kick off these commands using the CWPM data model the way it is. Huh? Oh, yeah. Better? I'll do that here too. And so you can see the difference here. Woo. There we go. Is that you have the command with the input arguments and the output arguments, whereas before you had to kick it off with a parameter, include these as sort of your input arguments, and then you would either get a response through an event, a CWPM event, there are some CWPM based commands that actually just store all the results in the table for you to look up later. So USP does this by defining two types of commands. There are synchronous commands and asynchronous commands. Synchronous commands give you a response right away over the USP message channel, right? So it's delivered, all of the results are delivered in your operate response. And then an asynchronous operation creates another process where it basically waits for the device to finish what it's doing and has a way to notify when it's done through a subscription. And then there are some TR-181 commands that have events associated with them, like like obviously the boot event, right, is related when you would call reboot, right? So you want to subscribe to the boot event, and they're not necessarily tied together. They just are made to work together. A synchronous command is super easy. This is from TR-069. You call it, the operation happens, you get your results in the response, and everything's done, and everyone's happy. There is a nice little mechanism here called send response, which you can set to false if you want, if you don't actually care about the results. For situations where you need to do something very quickly, and you don't care what happens. An asynchronous command is a little bit more complicated. The idea here is that you call it, the agent makes a request object so that you can later cancel it and know a little bit of information about it. And then when it is done, there is an event triggered called operation complete that has to be subscribed to by the controller in order for it to happen. And this is nice because again, we've offloaded a lot of functionality to the data model, and this lets us replicate so many of those things that we had to do.
Aspect about this. This also allows you to do multiple things at the same time. So, for instance, you can set off multiple diagnostics at the same time, whereas previously it was only one kind of action at a time.
Yep. Okay, events. Events in TR-069 are once again defined in the protocol. Those are your familiar things like bootstrap, transfer complete, all those things that are conveyed in the inform. And we ripped those out in USP, and so there are some notification types that are native to USP, and then there is one that's generic called event. And event basically just delivers you a path to the thing that happened based on the fact of whether or not you have a subscription to that event. An example is device.boot. That's probably the most well-known. The biggest functional differences between 181 and in 181 between the two protocols, and this is what I realized what some people were asking about before, are yes, everything is backwards compatible except for a few things, and these are a few of those things. And it's not that the underlying functionality is not backwards compatible, but the way that you do them is different because now it's done through the data model instead. So I showed you an example of diagnostics before in TR-069. You run it by setting a parameter called diagnostic state, and then the results are stored in the object's parameters, right? And as Daniel said, that made it so you could only do one at a time. Not just for that reason, but for a number of other reasons. And then in USP, we just do it by using the operate message, and the results are returned using those mechanisms. If you have a subscription, which you'll be very happy, events need a subscription. Firmware management is a little different. That's handled via the download RPC that everybody knows well and loves, hypothetically, in TR-069. It was done through the transfer complete, and I mentioned transfer complete event overload here because it was used for a lot of things, not just download and not just firmware updates, right? And it implied a lot of things, right? So like the download RPC, when you're using it for firmware, was entirely based around the idea that when the entire process was complete, the device has upgraded its firmware, is done doing so, and is ready for it, right? And all of that was implied by the transfer complete message. It is broken up now. But I do want to point out that the new way of doing things in USP is possible in TR-069 because we added it in Amendment 6. We at least added the data model components to handle firmware banks effectively. More than one type of firmware image on the device. You either activate the ones you want, get rid of the ones you don't want, install them in memory where you want them. And so we did that in TR-069. So it was in the data model, and then we converted that over to USP using commands and events. And we also sort of decided to rely on that entirely. There are several commands that are in device.info.firmware image that includes download, which has the optional auto activate. This uses the transfer complete event, but again, the event is defined in the data model. It's used using the event notification and activate. So you can do those things separately if you wish. And I will show that to you right now. Oh, hey, it zoomed in for me. Thanks, Firefox. Okay. This is device.info.firmware image. Can everybody read that? Or is it really? This is your dark mode. Dang it. So here's the download command, and now you can see all of the familiar things that you would have put in the download RPC of TR-069. Right. There's the activate one, which simply just takes a reference in the firmware image table and tells you when you want to do it. It's a very, very big file. But that's the difference, right? And so, as you can see, firmware image is a multi-instance object. So you, depending on the resources of the agent, you probably have a fixed number of spaces for these, but it allows you to install a firmware image in one place and deal with it later. Software module management is also different. This was handled entirely via RPCs in TR-069. Those RPCs were originally defined in TR-157, which is why everybody calls it that. But eventually, that was obsoleted. They were all moved to TR-069. But in USP, we did the same thing. That is totally ripped out, put in the data model, operates the same way by using commands and events, all of the functionality that you're familiar with. And for using software module management, using TR-069, all that functionality is there. But all of the new functionality that we're defining, especially and particularly around the notion of managing containers and applications installed on the gateway, is only done by USP. That's actually an interesting thing to bring up, because I know we do say we try to replicate everything in TR-181 when we publish it twice, with the exception of those things that are generally protocol specific. There are some things that are beyond protocol specific that will only be capable with USP in the future. Well, I'd be thinking like any of the new software module management things, we're not putting them back in TR-069. So
the data model is there, only the activities that you can do, like install stuff, that's right. Only available in USP.
Right. Yeah, go ahead. Oh, yeah. Yeah, I didn't yell at him at all. Did you see that? It's because there's nobody on the call. Okay, and Reboot obviously is different, which is one of the most commonly used RPCs in TR-069, but it's now handled via the Reboot command and the boot event. And there is a selection, there is an object called boot parameter that is controller specific that handles what you want to include with that boot event. Events need a subscription. I'll say it again.
I think that's an important point to make, because in TR-069 actually there are some implicit notifications that you would get, like boot, reboot, yeah, those transfer complete events, notifications, etc. In USP, there's none of that. If you don't have a subscription, you won't get any notifications. So that's very important to take care of that. That you actually need to create a subscription, otherwise the device will not send you anything that's happening on the device. Yeah.
Here it is. This is the subscription table. This is manipulated using add, set, delete. And it lets you create a notification, tell you what type it is. If it's event, you put in you put which event you want in the reference list. You say whether you want it to persist across reboot, things like that, how many times, if and when you want to retry it, and how long it should last.
Right. So just stressing the point, because this is often a point of confusion. People expect it to behave in the same way, like getting a boot event, like in TR-069. You don't get that. You need to subscribe to it.
Dallas?
if you have more than a use case for you have multiple controllers, each one caring for a different use case, you probably don't want to be receiving events for what the other controller is doing. So that's why that's why you have to subscribe it, because maybe you're not the only controller talking to the agent.
Right. Yeah.
Sorry for crashing your show.
No, please. We've had these conversations when we were designing these slides together, so by all means. Okay, the other big difference between TR-069 and TR-181 regards how they are addressed in the protocol. There are different paths and syntaxes in USP. If you remember complete paths versus partial paths in TR-069, that's not a thing anymore. But in the interest of making sure that things weren't confusing, we made sure to clarify that an object path is what we used to mean by a partial path. There's an object path, which is basically just a path that ends in a dot that's going towards an object rather than a parameter command or an event. There's an object instance path, which you would know as something that ends in either an instance number or now addressed by unique key. And that is also how we support the search paths, which I'll get to in a minute. We have very, very clearly defined the difference in USP between the supported data model and the instantiated data model. And that's awesome because it allows us to communicate things about the supported data model in the protocol. And my last few slides are about that because it's one of the most powerful features. But the point behind it in addressing is that, if you're using curly eye braces, it means you're probably talking about the supported data model and not the instantiated data model. Commands end in parentheses like that. The arguments are conveyed in the operate message. So there's a mechanism for conveying what arguments you want and what their values are in the operate message. Events end in an exclamation point like device.boot. And addressing in USP, you can use relative paths. So a lot of the messages, either when you're doing the request or the response, you reference the object that you are looking to, you reference the object path that you're looking to operate on, and then you don't have to keep repeating yourself over and over again in the rest of the message, which saves a lot of space. Okay, search paths. TR-069 added wildcard support in Amendment 6. It's there. It works in theory.
And alias-based addressing.
What's that? Oh, and alias-based addressing, right. Which is a short way of doing unique key addressing.
Yeah, so basically instead of using instance numbers, you can also use the keys, the alias parameter,
right,
to address objects. So that makes it easier to label objects and do operations on
which
them.
Is important to note that the alias parameters that are in the entire data model did carry over to USP, so you can always still use that, just not necessarily in the same way that you would have before. USP has search paths by design. So in addition to wildcards, you can specify a search expression rather than an instance number or a unique key. You can specify a search expression. So you can say, I want you to give me every single Wi-Fi SSID that is currently enabled, for example. And those can be used with subscriptions too. So that pathing can be put into a subscription path. So you say, I want to subscribe to everything under this tree that is currently in this state. This is the best part. In TR-069, we had to figure out what a device does entirely out of band. You either had to use the device type schema, which lets you specify an XML document that said what your device could do, which is very awesome and works very well, but not very many people other than Daniel use it. But or informally via whatever mechanism. And I'm sure anyone with TR-069 is intimately familiar with how many XLS documents were passed around that just have a list of parameters and what they're supposed to do. And that's terrible. The other mechanism you could do would be to try to walk the device, in which case you're just interrogating the instantiated data model to find out what it does using get parameter names, get parameter values. But if an object didn't exist, if there were no instances, then it doesn't exist, and you wouldn't even know that it's possible. So you would have to try to guess and go through and add things. And I can see the HDM guys shaking their heads, having used HDM in the past to do testing. It was quite a process, and so you had to basically supplement it with that object to try to get it into a state where you could actually figure out everything that it does. It didn't work very well. And then if you wanted to find out what operations it supports, you can get RPC methods. But if it said anything that was vendor specific, oh well.
And it also didn't say what parameters you have to pass. So that's also like completely, okay.
It's literally just the name.
You only get the name of the RPC, and the rest is best guess.
Yeah. So in USP, we have get supported DM, which is magical. Real quick on the difference between the supported and instantiated data models, right? This is kind of a zoom in of one of the diagrams from TR-069. The supported data model is everything the device can do, could do, and the instantiated data model is its current state. And we have different mechanisms for interrogating those things separately. In USP, we have get and get instances for the instantiated data model. Get acts exactly like you expect it to, and get instances basically summarizes the instances of multi-instance objects for you and gives you their unique keys so that you can later address them via unique key. And then also get supported DM or get supported data model. In terms of the addressing, get supported DM uses this I path syntax, and it tells you what a device supports. So we'll go through and if there happens to be no instances of a particular object, but it definitely supports that object, you'll find it. It'll come back. It'll tell you everything about it. You can flip some flags of whether or not you also want to know all of the parameters, commands, and events that it supports. It's effectively a very quick in-band short way of getting an entire data model from a device. And you can also do it very specifically. So if you only want to know like the objects and parameters that are under a particular piece of functionality, you can do that too. And then in USP 1.3, because we're starting to go down this road of applications that get installed on the gateway and then reveal the data model things that they can do, and some of those things might be very specific or different than so you might have two objects of you might have two instances of the same object that support different parameters. You're able to query that. It's a little more complicated, but you can basically say, hey, what does this particular instance have in its supported data model versus a second instance? We call that the concept of divergent paths, and it is unfortunately necessary in this new world. All right. I realize that was a big brain dump in a short period of time. Obviously, we're always at your disposal to answer questions, especially on Slack or anything like that. And many of our companies have multiple training resources in this department. But the key conclusions here is that we did keep device 2 for backwards compatibility. Some things are done differently, and so we publish it twice. They can coexist with one data model with these exceptions. And USP makes things much easier in a lot of different ways. And I will bring up where you can find these things. I know I had it kind of a complicated mess of things, but if you do want to know, so you can find the USP versions of the data model at USP-datamodels at broadbandforum.org. It's all published in HTML and the CWP versions.
And they're also cross-linked. So if you go to, or if you find one of the sites like usp.technology, then you can also get to the rest of the stuff from there.
Mm-hmm. All right. Any questions?
So thank you for this explanation. This was really helpful. And I'm wondering, in the context of having a dual, let's say, stack of the protocols, TR-069 and USP, and trying to model build the support data model in the context of those functionalities that are modeled in a different way by those two protocols. For example, software modules, which is a really hot topic for the operators these days. We have a profile defined in the CWPM version of the data model, but we don't have one in the USP version, and I now think that I get it why. So if you be considering building up a data model of the CP supporting both protocols, would the profile, CWPM profile, together with the USP commands and events be a complete set of the elements to support both protocols, or what?
So this has come up. We did make we made some assumptions about how people would implement certain things in sort of logically keeping things separate. That's not necessarily the case in all ways. The idea is that you're not going to have two entirely separate APIs, even if they're actually the same. You're not going to have two instances of it, right? Just to handle USP versus TR-069. The profiles did carry over, so I think a good way. I do think that a good way of figuring out what a device actually supports and being confident that it does so is taking the data model profiles and matching it up with what you get from get supported DM and being sort of like, okay, that's, but it's there shouldn't be too many differences there in terms of profiles and how to define them.
Yeah, but one important aspect about the profiles is also they're like suggestions, right? So people have figured out, oh, we typically need this kind of information in the data model in order to implement a certain use case. And that's what the profiles are. They're like, best practices that some people said, we need these like all the time. So yeah, they're suggestions, but there's more to that. So
I would say probably to the heart of your question is, what's the single source of truth? It's get supported DM, right? When the device tells you what's true.
Yeah, of course. Profile is a minimum set of elements needed to build up a specific functionality, right? And it's usually helpful when the customer comes, and most customers are like, we are the customers. We sometimes don't know what we want, but we want it now, or we want to see it on your roadmap.
No, you're right. The profiles are meant to be like guidelines, right?
Yeah. So they're really useful guidelines. So I think that's good to have it.
And also, spoiler alert, we are going to talk about exactly that in right a moment. No, but how you use the data model, or what you can expect, and how it is working.
Yeah. Any other questions? You want to jump right into that? Oh, go ahead.
Are there any specific use cases where one would use synchronous actions over asynchronous, or the other way?
That is entirely defined in the data model. So a command will always only be sync or async, and they tell you which one they are in the data model.
So it's for specific commands, yeah? Okay.
Yeah, so some things are synchronous by nature and others are asynchronous. So that's when you would use it. So basically, if it is expected that some operation can take a while, like firmware download, that's definitely going to be asynchronous. For some other things like reboot, for instance, you typically expect to say to the device, okay, I'm going to reboot, so it's going to be synchronous.
See this little flag right here? Every time you see a command, that'll be there. It'll either say sync or async.
Yes, the data model will tell you. Any other questions?
So I actually have a question for you, but now I think I'm ready to ask it. So you mentioned on the previous presentation about edge computing as a use case for USP that was not possible before.
That wasn't edge computing, that was edge computing.
Yeah. Okay. And then
I do.
and then I
use
wondered
scare quotes.
what the hell, right? So now when I know what the differences are in the protocol, maybe you can explain. Did you only meant the notifications or something more than that?
No, so as Jason mentioned, we now have this concept of the search paths, which basically allow you to filter the information that you want to receive from the device directly on the device. So you can use this both to implement conditional things. So you can, for instance, say, add an object if some condition is fulfilled. You can say, give me this information if some information is fulfilled, like Jason mentioned, give me all of the information about some network interface if the network interface is actually up. So you basically can tell the device, filter the information that you want to receive directly on the device rather than getting everything and then processing it on the server side, and drilling down on that.
Right. Thanks.
Are there data elements in TR-181 USP version?
Careful with the word data elements.
Okay.
Do you mean capital DE data elements or
can you
the general concept of?
Then I rephrase my phrase. Can you confirm that TR-069 data models are completely replaced or can be transferred completely into TR or into the USP model? So are there some left which are not?
There are two exceptions. One is pieces of functionality like this that was transferred over into a command, right? Three exceptions, excuse me. So one is that. Two are the things that are just there only for the purpose of those protocols, right? So the entire local agent object is only relevant to USP, right? So it's not going to be the same.
Okay.
And then the third exception is those things that are new, but so outside the use case scope of TR-069 that we were not going to tempt fate and put them there.
So basically everything that would require touching the TR-069 document to explain how it works is not going in.
So like, for example, IoT capabilities, I don't think, did we publish it? Oh, we publish it in both, but we don't describe how it works in TR-069.
Yeah, but all of the new functionality that we have, for instance, in data elements, getting back to that. So data elements is, its own specification. So there are lots of commands, so things that you can actually do to an access point or a Wi-Fi network, and those have no equivalent in TR-069.
Actually, no, that is a great example. So like there are commands that are defined in data elements that we imported through the work of the WFA. The only way we could ever put those into TR-069 would be to add new RPCs, and we're not going to do that.
Or data model.
Or the complicated.
Okay, but despite the local agent branch being only used in the USP operations, it can still be provisioned with TR-069, right? Or not?
We do have a slightly separate concept for that. So we basically have parts of the USP specific data model republished in another area. So basically that you can configure the USP controller from a TR-069 ACS.
But the name is different.
The name is different.
Yeah, because it is meant to be a piece of functionality we exposed to an ACS for it to do very specific things and not everything, right?
Having said that,
there's an open issue.
No, there are actually people who implement basically the same data model, and they share parts from the USP data model in TR-069. They shouldn't, but they do.
And I don't think we ever said not to. All right, why don't you jump in? Because I bet there will be a lot of questions that are just answered by what you're about to say. Go ahead.
So correct me if I'm wrong about those search paths. So for example, if I would like to get all the information for one bridge that is configured on the device, this search path thing would just show me everything that is related to the bridge, like for example, device IP interface, device Ethernet, the device Wi-Fi, and all this stuff. Like this will help me with that. Yes.
Yes, it would. So we have actually a lot of capabilities in the search path. So we have also implemented something called reference following. So you could basically say, if you have some attribute in the data model that's actually referenced to something else in the data model, you can say, if that and that and that follow this particular reference and get to the object that is referenced by
like
that, and
searching lower layers here and stuff.
sorry,
Searching lower layers values for
basically everything that is referenced, you can use and use the reference following feature to get to that. Okay, round of applause, maybe.